Hello, friends. Welcome to CIS116, where we will be using Python as our introduction to programming. And for this introduction to programming, we will be using Microsoft course number 40460, and 40461, and 40521. Not to worry, they're just the numbers that are going to be on the books and the assignments. Microsoft Imagine Academy produced these 3 little mini courses that we put together to make CIS116 awesome. So I hope you enjoy this. If it's your first programming experience, welcome to the club. This is Module 1, where we're going to talk about these things, these kooky programming languages, which are ways we talk to computers to get computers to do things that we want the computers to do. So some of these might look familiar. You might have heard of BASIC or Pascal or Visual Basic, or maybe not. Maybe you've never been interested in programming languages at all. I hope we can present this in a way that you find it at least interesting and useful when it comes to thinking programmatically, which is kind of one of the things we're trying to get out of this course. So what and why is Python? It is a modern, interpreted programming language. We talked about that last slide. Created by this dude, Guido van Rossum. So he's awesome, cool guy, interesting philosophies. Modern, meaning that this is a relatively youngish language. Some of the programming languages we use go back to the 60s and 70s, and this one's moderner. It is interpreted as opposed to compiled. An interpreted language is interpreted by an interpreter, like when you speak Spanish and I don't, and I need somebody to interpret for me. So this here window is the Python interpreter, and it is doing that work. And if I go into here and I change the font, I can even make it a little bit bigger window. So how's that? I like that. Let's even use bold. Boink. So here is Python 3.7. We're going to look at 3.6 because that's what Jupyter Notebooks support. There's not a ton difference. A cool Easter egg you can do in Python is import this, and if it's the first time you've done it, you get this output, the Zen of Python here by our friend Tim Peters. I've been banging around on this console for a little while. That tells you sort of about what we're going to talk about here. That beautiful, obvious, simple to the programmer, and allows us to be complex or simple without being complicated, and that it stays readable. That's sort of the philosophy that's been laid out by our man Guido here. 2 and 3 are under active development. We'll be playing with 3.6, and if you want 7, you're welcome to install on IDE or Python directly. PyCharm's fun. I'm a fan. I have not had enough time to play with the Microsoft Visual Studio implementation of Python to give it a real thumbs up or thumbs down just yet. I haven't had to use it for any programming projects, so I'm on the fence. I welcome your feedback. Python's also cool because you have to do less code to start doing useful stuff. You can, with very few lines of code, pull in some modules from other code authors, or programmers, as sometimes we like to call them, and use that to get stuff done in a big hurry, which is useful. And why you'll find Python being used, and in particular Python and Jupyter networks, being used in fields like artificial intelligence, machine learning, and data science. Also why we'd like to introduce it to you early in your academic career. This is just sort of how this set of PowerPoint slides is going to lay out code. So you'll see comments in that particular color, keyword, string, function and reserved words, etc., like that. And if these words don't mean anything to you, reserved words, functions, don't worry about it just yet. We'll get there. But that's how it's going to show up on the screen. If you're colorblind, it might not, it's various shades of gray. Don't worry, it's very intelligible just as black and white text. So on the programming. If you remember functions in math class, I'm pretty sure I don't at this point, but basically just a function in this context is a little tiny program, like our friend print here, because you can't have hello world without a print function. That does a thing. It returns, you give it something to work with, and it will return a value to you. So in this case, print takes some sort of input, in this case a string, which we'll talk about in a bit, and returns output to the user, which is cool. That's a useful thing to do. A string is a data type, which is simply a type of data, right? There's a bunch of different kinds out there. Mostly the important stuff is going to be stuff that works with numbers and text, because kind of what you deal with a lot in programs. That lets you deal with fun things like videos and audios and stuff like that. The string, in this case, is simply a series of characters enclosed in quotes. So in this case, this is some text to output to the user, is a string that is going to be given to the print function, which is a new thing we just learned about. That's pretty cool. And to output something to the user, so to return stuff to the user. And I think I did that in my compiler up here. So if I just print some stuff, the computer passes that back to some stuff string to the print function and returns that to the user. Sweet, right? If you're going to be writing programs, which you're going to be doing in this class, it must be commented. That's important. The interpreter, in the case of Python, or the compiler, in the case of a compiled language, is going to go through and ignore that. It's not for the computer. It's for us, the humans. So in Python, it will be interpreted by that black box I showed you, the Python interpreter, or by your Jupyter notebook as you go through and practice on those. In a compiled language like C, the computer passes that off to this thing called a compiler. It does some magic and spits out a piece of code that only the computer can use, which is depending on what you're working on. So comments are ignored by the computer, but useful to us because we want to be able to figure out what the heck it was we were thinking when we wrote the code. So in Python, you put a little hashtag in front of things, and in this case, the code works out like this. This is my first program. It says hello world, and it says what we're going to do. So cool for us. Very useful to have lots and lots of comments in your code to explain to yourself what you're going to do with that code. You will read your code many more times than you will actually write it, and sometimes you'll be writing it and you'll read it and mull it over and trying to figure out what you were thinking when you did that. So very important, and a thing you get graded on. So make useful comments. Variables, if you remember algebra, are just basically this black box into which you can put a value. They're stored in memory. That's kind of not germane. But in this case, we've created two variables and we've put those values into those variables, and then we've used those variables to create another value for a variable, which we'd assume probably come in somewhere around 5. That's how we use variables to store values. Those values have a type of data. I already mentioned that there's these string things, but there's also integers, which are whole numbers, counting numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, and the number line. So, going the other way, 0, -1, -2, -3. So those are integers. They have no decimal places. If you want decimal places, you need to have a floating point number, a decimal number. When we're creating these things, it's useful to remember that strings use quote, instant float don't. Some languages, unlike Python, are what we call strongly typed, where you have to assign a variable a type when you create it and then put a value into it. In Python, we don't assign the types to variables. We sort of let the interpreter figure that out for us. We want to help it along as we're doing that. It's important that we get the right types of variables into our code. But it's not so hard that you can't handle it yourself. So in this case, we make a var name with a value, something like this. So message is equal to this string. So we've made message a string just by setting it up like that. Remember that case counts. So num1 and num1 are not the same thing. Capital N will throw you off there. You look at this piece of code here, and you might assume that num3 should equal 3, right? Because 2 + 1 is 3. Well, a stupid computer can't figure that out. In this case, it will actually return an error. Because what's going on here is we've actually created num1 as a string, because strings use quotes, and num2 as an integer. And you can add an integer to an integer, and you, in fact, can actually concatenate a string to a longer string, but you can't mix and match the types. So you wind up with this error, this type error that says, hey, these are wrong. Num1's a string, can't add strings together. That's a problem. It makes me sad. It makes me sad when we get type errors. So important to remember what's going on when things are happening. Now, as I mentioned, you can actually use the plus sign to add strings together. Add strings together. So you can add strings together. You technically concatenate them. We're using the plus sign. Fancy programmer types might say things like, we are overloading the plus operator, but that's fine. Plus adds numbers together, and it also concatenates strings together. Just FYI. Remember that variables are a box, right? So you can put a value into them. So we put 6 into num1, and then we print it out, and then we put another value into it, and we print it out, and the value changes. It's just how that works. The new value overwrites the old, and that's kind of one of the reasons that they're useful. You can, in fact, mix and match the combinations of variables in text inside of our friend, the print function, right? So you can make this message 1, print it out, and then print out message 1, which is a string, and we're going to concatenate it with Mr. plus sign here, or Ms. plus sign perhaps, and get something that looks like that. So we can mix and match hard-coded values like Justin here, which is bad practice. We wouldn't want to do a lot of that to create code. Since we've got this business with the type, we can have a type of variable that's a string, we can have a type of variable that's an integer, and we can have a type of variable that's a floating point number. There is a useful function out there called type that will let you know what type of variable you're working with. So if I do, instead of print some stuff, I do type some stuff, it'll tell me that it happens to be a string. Cool, right? Since we're not strongly typed, we're not assigning it, and maybe we get a little confused inside of a big program, and the next thing you know, we've got some confusion going on about what it is that code actually did. So you can also do this concatenation business while you're assigning a variable. So here we're creating the message variable out of name1 and the pre-message. So you can lump those things together. Totally valid, acceptable thing to do. It just particularly useful when you're taking outputs from functions and stuff. That comes in handy. So there you go. You've actually even already seen an example of that previously. Sometimes when you're writing code, you run into errors. Any one of these errors could also be called a bug. Bugs aren't a specific type of error. So errors can happen in your syntax. They can be syntactic errors where you usually either are messing around and accidentally type something. Frequently, you will use a like a space or something that's messed up. For example, here we've used a keyword while, which is used to set up while loops. You can't use keywords for variables. Functions need colons at the end of them before they run. So in that case, you've failed to put the colon in. This one's sort of tricky, and you will run into it from time to time. In the Python language, the equal sign is for assignment, right? You assigned a variable using x equals 3. You don't use that when you're trying to use a comparison. In that case, you use the equal sign twice to see if x is equal to 3. So there's a comparison. symbol, the equals, and then there's the assignment equals. So things that you will bump into, which will make you sad, and you will notice that you have created an error, which is not great. A runtime error is like syntactically correctly. You put the equals in to do your comparisons and stuff, but it does something like that the computer cannot do. So in this case, computers and math in general can't divide by 0. It's just not a thing. Division doesn't work that way. And if you try to do that, the program will stop and say, hey, you need to go and figure out how division works. Infinite loops actually technically valid. Sometimes you want a program to run infinitely long, but generally that may lock up if it is a very small loop. So if you've accidentally forgotten to exit out of a loop or something like that, you can wind up with code that just goes and locks right up, which that's bad. You don't want that. Logic errors are a bummer and some of the hardest types of errors to find when you've got code that you think is right, but doesn't do what you expect it to do. And that's one of the reasons why we have to test our code with various inputs to make sure it actually does what we think it does, and to include edge cases in that testing to make sure we're testing for all the little fiddly bits that could get us in trouble. So if you thought, the example we're going to give here is like, if you thought you were supposed to do 2 plus y, but instead you did 2 minus y, that program is syntactically correct. It runs just fine. It's not going to have any runtime errors. That's a perfectly valid operation. But the thing we wanted to do was to do something differently. Like maybe we typed the plus when we meant to type the minus. Maybe we did a less than when we should have done a greater than. If we have a loop that doesn't actually exit out, for example, if we wanted to say do this while x is equal to 0 and x will never equal 0, that's a problem. So Python will raise these errors for you. So in this case, we could run into a type error when we're trying to do something like we were doing before, like if you try to do math on a string, that'll get you into trouble. A syntax error when we've got something where we usually made a typo. And a name error when you use a variable before you create that variable, or if you use you think you are trying to use a command that doesn't exist, usually again when the programmer makes a typo. So type errors, math with a string, that's bad. Don't do that. It doesn't work. So one of the fun things you can do with our friend the print function is you can create ASCII art or character art. All right, so it's not a ton of fun, but it is a thing you can do. The print function there will spit out a lovely A. Another function you're going to get a lot of mileage out of is the good old input function, which will let you take something from the user, such as like your name here as illustrated in our code, and then assign it to a variable and do something with it. So here we create a variable named, appropriately enough, name1. It takes input from the input function that starts with this string. So this is what it's going to show to the user. And then it's going to sit there and wait for that input. And then it assigns it to the variable, prints out the variable. So cool, huh? You can do that a bunch of times and store that different stuff into a variable. So here we're going to take input for grade 1, 2, 3, 4, and 5 and do something with them, right? Maybe you'd take an average with that sort of thing. But a useful way to get multiple pieces of information from the user. Input, for security reasons, always takes data in as a string. And therefore, you might have to convert a string to an integer. Input's always a string. But don't worry, we have handy-dandy functions to convert between types. So since Python's gone through and turned our grades, in this case, into strings, if we want to do that math on them, we have to use something called a type conversion to cast. It makes you feel like a level 1 wizard in Dungeons & Dragons. You cast the data type. To cast that, you invoke one of these keywords, int stir, to change our strings into integers so that then we can do some math on them. And notice that we can use this int function right in line as we're trying to do our math to add up the sum of our grades. Pro tip, you can't do something like int grade, and do the math in there. It will concatenate those strings, remember, so mush them all together. So you would get a much different result. Be careful. Then once we've gone through and we've summed up our numbers, the average, if I remember correctly, is the sum of x numbers divided by x. So in this case, we had 5 numbers to sum them up. Add up all 5, divide by 5, and then we can print out our result. Ta-da! But to print it out, we flip it into a string. We may not have had to do that. We can do that. Pro tip here, since we've done some math and it didn't work out exactly, when we divide things, we're going to create a floating point. We're going to use the next one of our data types. So you might want to format that a little bit. It's nice to have your output neat and tidy. So you may influence the good old print function by using the comma method here. So we print the averages, quote, comma, stir average. You can mix and match those, combine things together to create, the kind of formatting you're looking for. Nice to tidy up your stuff. In this case, we worked out our average, and it worked out to be 94.6 for those. And notice that this space, created by our friend the comma here, appears, which is great. So I mentioned this, that we need to put quotes around our strings. But sometimes you need a string that includes a quote. Well, lucky we've got this extra character laying around on our keyboards that we don't use, except for apostrophes. So you may switch around the quote or apostrophe and thus like. So if you needed to put that in there, you may. And then that way you can get output with strings on it. So it is a problem we anticipated, we thought about it. Perhaps you've heard of Mr. Boole and his Boolean algebra. What is that Boolean business? If you ever saw the original Tron movie, there was this thing called a bit that was following the main character around. And all it could do was say yes, 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 or no, no, no. Well, that's a Boolean value. Boolean values are either true or false, on or off, 1 or 0. We get a lot of mileage with Boolean algebra and choices in the old computer science realm, because it's the only thing computers are really doing. There's only zeros and ones on those things. There are a bunch of built-in methods to test strings. So all of these do kind of what they sound like. They're a test for a string to find out, is it an alphanumeric, or is it an alpha? Is it a number? Is it a title? Is it a digit? Is it lower? Is it upper? Which are useful. So if you've got a message, you can test that string with the is alpha. So it'll return true if it's A to Z, upper or lower, but that's it. It will return false if you give it a number, because it is a number, not an alpha. For that, we have the isNumber function, isNum, and it will return true if it's either all alphabetical or digit, but not if it is a symbol. So third is, in fact, there's a number in there. Exclamation point, not so much. If all the words in a string are capitalized, it is a title case, which is not exactly title case. The English majors will, but if you want to know if all the letters are capitalized, that'll tell you. Is it a digit? So if you don't care if it's a number or not, like third or 100th, 0, 1001 is a digit, third is not a digit. There's something out there. Is it uppercase? Is it lowercase? You're getting the idea here. Starts with is interesting. So if you want to know, does the string in question start with, say, the letter M, returns true. The uppercase M, if it's a lowercase, returns false, because remember, case counts. It's important. You can do a whole string. So you could do my, if you spelled it right, and it would return true. You can use those methods sort of like in the reverse to do things to strings as well. You can format them. So you can use the same type of setup to capitalize, lowercase, uppercase, swap case, to switch upper to upper and lower to lower, and title case. Again, to test that incorrect, somewhat, title casing. So here, if you take input and you upper it, whatever you input, so in this case, Alton, will turn into uppercase Alton. You can do the same thing with like a print function. So if you want to, here's our message, you want to switch it over to title case, so all you do is put the dot title method at the bottom, you're rocking and rolling. Another useful way to check through things is with the old in keyword, which will do a quick simple search and return the Boolean result. So it will return true or false if it turns out that that text is in a string. So is Eric in the message? In fact, it is. So this Boolean test will return true. If you input Eric, if you put something else in, your mileage may vary. So there you go. There's a little introduction. Have fun in the practice files, reading and computing, and we'll see you next time.